Hey guys, Mr. Mackey here. Now, yesterday I introduced you to inequalities and I was showing you how to find a range of values for x. And I gave you this challenge where we have the equation x squared plus 3x plus 2 is less than 0. So we need to find the range of values that are less than 0 that work for x. Now, like a standard quadratic equation, what you have to do is factorise it. So we factorise by finding two numbers that multiply together to get 2 and add together to get 3. That's x plus 2, x plus 1, and that is less than 0. Now from this, we now know the solutions of x that are involved, which are -2 and -1. So how do we write the solution? How do we write our answer? Well, once we go past -2 to -3, -4, -5, we actually find values that are greater than 0. When we get to values that are past -1, so 0, 1, 2, 3, we also reach values that are greater than 0. But we only need to think about the values that are less than 0. So we have to say that the range of values are between -2 and -1. But how do we write that? So we put our x and we put it's less than -1, but it's greater than -2. That's what we're saying. -2 is less than x, or x is less than -1. That's the summary. And that basically is telling us that the range of values for x are between -1 and -2. Now we're going to be focusing on algebra again, because it's algebra week, but we're going to be looking at something a bit more different. Something you probably won't even learn till year 11 or even college. Let's check it out. Now for the next 2 days, we're going to be learning about things called differentiation. And differentiation is how we can find the gradient of certain equations. It's such a cool method. It also looks at the rate that things change. So for example, it helps you find the rate of how populations increase, stuff like that. But how do we find a differentiated equation? That's what we're going to do first. Now I have the equation y equals x squared. Now when I differentiate an equation, the y will become dy over dx. Now this means the differential of y over the differential of x. That's what it basically means. And do you remember what the differential of y over the differential of x is also known as? The gradient. That's how we know that differentiated equations can find us the gradient, because that's what this is telling us. Anyway, how can we differentiate this part of the equation, however? The first thing we need to look at is the indice, which in this case is 2. That's the most important part of this equation. What you need to do is you multiply that indice by the coefficient in this equation. Now in the coefficient of this one, it's 1. We chose not to write it. So when we multiply it, it becomes 2. We're just multiplying it by 2. But we still have our x, because it's 2x. But then the final thing we do is we subtract 1 from the indice we started with, and that's the new indice of our equation. So we do 2 multiplied by x, but instead of x being to the power of 2, it's x to the power of 1 less that. So in this case, it would be x to the power of 1. So, can that be a bit easily written? Well, yeah, it can. It can just be 2x, because you don't need to include the 1 at the top. It's the same thing. And that's how you differentiate equations. You multiply the front of the x by the indice you started with, and then you change that indice by subtracting 1 from it. And that's how you do it. Well, what will this one look like? Y equals 3x squared plus 2x plus 6. Let's differentiate it. So the first one, we focus on our indice, the 2 here, and we multiply that by what's in front of our x, which in this case is 3. So we do 3 multiplied by 2, so the first part is the 6. Now what will our x now be to the power of? Well, we have 2 subtract 1, That means that this part of the equation will be x to the power of 1. Now let's do this one. 2x is the same as 2x to the power of 1. So we do 1 times 2, and that ends up with, you guessed it, the 2 that we started with, because 1 times 2 is just 2. But then we do 1 take away 1, so it's 2x to the power of 0. Okay, we'll tidy this up in a minute. Let's just worry about this bit. Now, 6 is exactly the same as doing 6x to the power of 0. Because anything to the power of 0 is just 1. But I'm imagining there's an x there just for the sake of argument. Now, what's 6 multiplied by 0? 0. And we just leave it like that. Now we can tidy this up. So we have our 6, and we have x to the power of 1, which we can just write as x. And then we have plus 2 times x to the power of 0. X to the power of 0 is 1. So the simple differentiated equation is 6x plus 2. And that's a differentiated version of this equation. So let's differentiate this equation nice and quickly before your challenge. So we have 4x cubed, or to the power of 3. You multiply the 4 by that 3, getting us 12. And then we have our x, but it's to the power of 1 less what we started with. So it's 12x to the power of 2. The next one we have 2, that's the same as 2x to the power of 0. When you differentiate that, that will just become, well, 0. Then we have minus 5x, and that's the same as minus 5x to the power of 1. Minus 5 times 1 is just minus 5. And then we just do it to minus 5x to the power of 0. Let's tie this up a bit. 12x squared we don't need to tidy up because that is the best way we can leave it. The 0 we can just get rid of because it's the same as just ignoring it. So 0 we're not going to write. And minus 5x to the power of 0 is just the same as, well, negative 5. And that's the differentiated version of this equation. So your challenge today is going to be quite simple. I want you to differentiate this equation. It's a bit different to what we've done already today, but the method is still the same. What might you have to do differently though? How might the method change based on what you're doing now? Good luck. I'm looking forward to seeing these answers. Take care and see you tomorrow for more differentiation.